Good morning interweb, let's world build. In this video, let's look at where to locate fossil fuels and ores on your fantasy worlds. Coal deposits are the remains of ancient tropical to subtropical swamps. Back when the climate was very warm and wet, plant life flourished in so-called coal swamps, broad, low-lying, waterlogged tropical plains. The waters of these coal swamps were anoxic, oxygen poor, so plants that died and fell into the water didn't rot away entirely. Instead, they just got buried under more dead plants, eventually forming a compacted layer of organic matter called peat. Peat contains about 50% carbon. If it were to get buried to a depth of about 4 to 10 kilometers, the temperatures and pressures present would concentrate the carbon to about 60%, the minimum needed to form the lowest grade coal. The more the coal is buried, the more concentrated the carbon becomes, the higher the quality of the coal. So, place your world's coal reserves in areas that in the past were low-lying tropical to subtropical swamps. Place higher rank coal in the foothills of mountain belts that formed in these regions. Do not, however, place coal reserves in the interior of mountain chains. The pressures there are such that 100% carbon, otherwise known as graphite, will form, not coal. And finally, place your peat reserves in your modern day, low-lying wetlands. Oil and gas are hydrocarbons, derived from the remains of ancient plankton, not dinosaurs, as you may have been told. Much like the formation of coal, when these plankton died, they sunk to the sea or lake floor, they accumulated and then mixed with the clay, forming a muddy organic ooze. The ooze was then buried and compacted, forming black organic shale. This shale is known as source rock because it contains the raw materials from which hydrocarbons form. If the source rock gets buried deeper to a depth of about 2 to 4 kilometers, the temperatures and pressures present produce kerogen. Shale containing about 25 to 75% kerogen is called oil shale. At greater depths, the oil breaks down to form natural gas, so oil can only form in a narrow window known as the oil window, typically at a depth of less than about 6.5 kilometers. The gas window is much larger, typically extending down to about 9 kilometers. Oil shale source rock is not very porous or permeable, so drilling into it doesn't yield much product. Luckily, oil and gas are less dense than water, so they'll try to escape the source rock and rise up through the ground to get above the water table. If not stopped, they will eventually reach the surface, forming an oil or gas seep. So for underground oil and gas reserves to exist, we're going to need a trap. Basically, impermeable source rock, permeable reservoir rock, impermeable seal rock. The oil and gas are generated in the source rock, rise up and collect in the reservoir rock, because they are trapped by the seal rock. Traps can be found in a variety of locations, on the crest of tectonic folds, along tectonic fault lines, or near salt deposits, to name a few. Side note, underground salt deposits may occur in regions that were once subtropical deserts. Salt, and also lithium, may also be, air quotes, mined in salt pans. Large, dried up desert lakes and ponds where evaporating water has concentrated the salt and lithium. Anyways, place your primary oil and gas reserves in regions that were once shallow tropical seas and lakes, source rock, but that then got buried by sedimentary deposits, reservoir rock, and thereafter underwent tectonic compression, trap formation. This is exactly what happened in the Persian Gulf, which is why 60% of the world's conventional oil and gas exist in that region. Additionally, secondary oil and gas reserves can be placed in sedimentary basins along passive continental margins. A sedimentary basin is a land depression which has been filled with sedimentary deposits. And a passive continental margin is where the land meets the sea, sans active plate boundary. Think the Gulf Coast of the US. And finally, place some oil and gas reserves in your foreland basins. Foreland basins are sedimentary filled depressions that form on the continental side of a mountain belt, as the weight of the mountain chain pushes down the surface. Metals occur natively, in their pure form, or as minerals, bonded to non-metallic substances. If a concentration of a metal in a mineral is significant, and the metal can be easily extracted, the mineral is said to be an ore. When an economically significant concentration of ore minerals occurs, we call it an ore deposit. Ore deposits form in many ways and in general are associated with volcanic activity. In a magmatic deposit, ore minerals precipitate in a magma chamber. In a hydrothermal deposit, hot groundwater dissolves ore minerals and carries them away, precipitating them into the surrounding rock. And in submarine vent deposits, ore minerals precipitate on the seafloor via black smokers at divergent oceanic plate boundaries. So those are some of the ways ore deposits form. Now, where to put them? Most of your world's geologically recent ore deposits will form around volcanically active plate boundaries, specifically in the overriding plate of subduction zones, and in hotspots. Think your world's equivalent to the Ring of Fire or Alpide Belt. Most of these deposits will be porphyry copper deposits. Copper only, copper gold, copper molybdenum, or molybdenum only. In all cases, minor amounts of lead, zinc and silver may also be present. Oh, and place a couple of tin tungsten deposits here too. Near these deposits, but still close to your volcanically active plate boundaries, place your epithermal gold deposits. Start with gold with minor amounts of silver and copper. Further out, place gold with minor amounts of silver, lead and zinc. And further out again, gold with minor amounts of silver and mercury. Surrounding these, place your IOCG deposits. These are usually associated with slightly older rock and are important sources of uranium. More on uranium later. IOCGs can also be placed in continental rifting zones. Next up, place your nickel-copper deposits and PGE chrome deposits. These should be few and far between and should go in your ancient cratons, the old, stable interior regions of your continents away from active plate boundaries. FYI, diamond deposits can also go in these areas, just make them very rare. VMS deposits are found in and around mountainous regions. That is, in both new and old mountain chains. These predominantly copper-zinc deposits formed in black smokers on ancient seafloors, where subsequent mountain building thrust them up to mineable depths. Expect minor amounts of lead, silver, gold, cobalt, tin, selenium, manganese, and cadmium. For similar reasons, place BIF deposits in and around your old mountain chains. Back when the Earth's atmosphere was really oxygen rich, the oxygen dissolved in the seawater, changing its chemistry such that it could no longer hold iron in solution. The iron precipitated as iron oxide, sank and formed layered sedimentary deposits on the sea floor. Place SEDEX deposits of mainly lead, zinc and silver in your continental sedimentary basins. These deposits should be fairly uncommon. And finally, place residual mineral deposits in your rainforests and other similarly wet regions. These form when extreme leaching of soil leaves behind concentrations of minerals such that the soil itself becomes a kind of ore deposit. Bauxite, aluminium, is usually mined in this form. Now note that ore deposits can go through secondary enrichment. Secondary enrichment zones form when groundwater leaches and dissolves an ore deposit, concentrating the minerals away from the original source. So throw a few of these in, downhill from the ones you've already got. In particular, make your dominant uranium deposit be a secondary enriched one. MVT, Mississippi Valley type deposits, form when groundwater sinks beneath a mountain range, dissolves metals, and then transports and concentrates them on the other side of a foreland basin. Again, throw a few of these in. Note that MVT type deposits can be hundreds of kilometers away from their source. And finally, throw in a few placer deposits. This is where a mineral or native metal outcrops, erodes, enters a river system and gets concentrated downstream. You know, panning for gold and diamonds. And that is that. One science-adjacent, overly simplified beginner's guide to plotting the locations of some ores and fuels on a fantasy world. Done. Good morning, INTERWEB. This video is sponsored by Campfire Pro, the writing software designed to help you keep your world building projects nice and neat and organised. Campfire Pro's character pages will help you keep track of all your characters, their backstories, and even their character arcs. The Timelines feature can help you plot out that sprawling epic fantasy you've always wanted to write, and Map View will help you create and manage all the locations in your settings. Also, check out the brand new World Building Pack. This expansion of Campfire Pro has even more tools to help you construct species, items, magic systems, religions, philosophies, and even languages. Start Campfire Pro's 10-day free trial today by clicking the link in the description. That way they'll know you came from this video, and afterwards, if you decide to buy, it's a one-time purchase. Once again, thanks to Campfire Pro for sponsoring the show and helping us all keep track of where exactly we placed those mining operations. Also, big thanks to all the patrons who help fuel the furnaces that keep Artifexian going. In particular, Alexander Roper, Andrew P Chehayl, John Hooyer, Ripta Pasay, Spencer Brownlee, Terrablae, and World Anvil. Thanks to you, thanks to Campfire Pro, and until next time, Edgar out.